Ma, አሁን ቦሌ የምትከታተይ እንደዚህ ነው። ቦሌ የምትከታተይ አሁን ሰዓት ሲደርስ እዚህ ጋር አስተማሪ ይመጣል። ይመጣል እና እንደዚህ ግማሽ የሚስትሪት ይሄ ግማሽ
Yeah. የአካባቢው ማህበረሰብ እዚህ ተሳተፉ ወጣቶች ኢንጂነሮች ማተሞች በሙሉ ለሀገራችን በጣም ጠቃሚ ተሰርተዋል። በጣም ጠቃሚ ድርጅት አድርገው ሰርተው ፈጽመው
ከአንድ አዳራሽ ይሻል ليفت سدست ليفت
በተያዘለት ጊዜ በጣም በአጭር ጊዜ ውስጥ እንዲጠናቀቅ ላበረከቱት አስተዋጽኦ ደግመን ምስጋናችንን እናስተላልፋለን። በምታውቁት ይህ ስፍራ በታሪክ የላቀ ስፍራ ካላቸው የአዲስ አበባ ከተሞች የአዲስ አበባ ወይዘሮ አዳነች አቤቤ ከከተማ አስተዳደሩ ከከንቲባ ጽሕፈት ቤት ጀምሮ እዚህ ድረስ እይታም ቅርስ ነው በሚል ርዕስ ተስፋ ሁለን እንዴት መመለከት ብለው ተነስተው ነበረ። የአዲስ አበባ ያላቸውን ምኞት ገልጸውልን ነበር። እዛም የነበሩት የክፍል እንግዶቻችን ቀደስ ነበር የተባለው እኛም በድጋሚ ስነስርዓት
Okay. So
now let's proceed to the 25th question. The pressure at the base of a so let's start the 25th question. Start 25th.
Okay, time starts now. Come on, guys. Okay, I see all the options being written D, A, B, C. Let's see who gets it first and correct. Fikir says D, Hemant says A, Yanet says B, Tarina says A, Asad says C, Lil says A. Okay, nice, nice.
25th questions. All right, we have a lot of mixed kind of answers.
Yeah.
So let's look at the 25th question. The pressure at a base of a container filled with certain liquid is found to be 500 Pascal. So there is a container. The pressure at the base is 500 Pascals. Now determine the density of the liquid if the height of the liquid from the base is 50 centimeter. 50 centimeter. So what do you have to determine? You have to determine the height, the density of the liquid. So the pressure is, how do you measure pressure? In terms of height and density, you measure pressure is measured as H rho G, where Greek alphabet rho means density, relative density. Okay. So the, the pressure is measured at as H, which is the height of the liquid column, rho, which is the density, and G, which is the acceleration due to gravity. Okay. And the value of G is already given to you as 10 meters per second square. So pressure, you already know. So 500 equals to H. So since I am using the pressure in SI unit, G in SI unit, so I have to put H, I have to put everything in SI units. Okay. So I will have to put everything in an SI unit. So pressure is already in its SI unit. H is 50 centimeter, but I have to convert it into meters because I want H in SI unit. So 50 by 100 meters, which is half a meter, 50 centimeter, into rho into G. G should also be in SI unit, which it already is. So if I do this, so I can say rho is what? 100. Okay. So the density is 100 in SI unit. So SI unit of density is what? Kg per meter cube. So the answer is C. Correct answer is C.
Okay,
Okay.
1 second. Let me see.
C.
It first.
C. C is the right answer.
Yeah, let me see who answered it first.
All right. Till
Yeah.
Shashi is doing that. So let me revise the concept. So the pressure is given by H. So when you have a liquid column, it is given by H into rho into G. Now you know the pressure already, 500 pascals. You know the height, 50 centimeter, which in meters would be 50 by 100. And rho, that is what you want to find out, which this you don't know. And G, you already know. So you can form an equation and find out rho. Okay, that's what I did. The only thing that you have to notice here is that you have to keep everything in SI units. So 50 centimeter is not in SI unit, so you will need to convert it into SI unit before plugging it in the formula. Yes, who won?
Great. So guys, I hope everything is clear, right, till now? I hope everything is clear.
Yes.
Great. So I will just probably take 15 seconds. So when we started the session, there were about 20, 25, 26 people. Okay. So now we have about 40 people. So I will just repeat for them. So guys who have just tuned in right now, what we are doing is we are running a contest. It is a 15-day contest. So what Manish teacher is doing is he will be asking you questions, and if you know the answer, you have to be the first one to answer it. If you do it, I am recording it, I am making a note of it, and I will announce the winner. So everyone who has joined right now, please be very active. Okay? Thank you. Yeah. Manish teacher, you will continue.
Right. Let's do question number 26.
Mister,
Start.
my chat is disabled.
I mean,
No, everybody's chat is enabled. I mean, everybody can type. You can go to the right side, click on chat and type. Okay? It's enabled for everyone.
we are doing the 26th question. So
Our
start.
chat,
Can you
our
just
chat
move,
is disabled.
move
It's still
the
disabled, mister.
In fact,
just
it's disabled for
The answer is
everyone.
A.
just move the slide up a bit.
A.
Just
My chat's disabled.
Yeah, so
It's
chat
A.
is disabled for everyone.
The chat
It's
is
A.
disabled.
It's A.
My child is disabled.
Disabled.
But the answer is A. Sure, my chat's disabled.
A.
A. The answer is A.
The answer is A. A.
A.
Wonderful. The correct answer is A. Wonderful. So
A.
A, sure.
wonderful, wonderful. So this is the correct scientific notation. So in scientific notation, you need to have one number, and after that number, you should have the decimal point. Okay, only after one number. So here it's 1500000. So after one number, just put the decimal sign. So then you'll have to put 1, 2, 3, 4, 5, 6. So all the things, they then after the numbers, just put so this as raised to the power. Okay, so this is the right answer. A.
So Brooke was the first one who answered. Great. Okay. So now the chat is enabled. Okay. There was some error, I think. Let's
Okay.
proceed to the next one.
Right. So 27th question. Can you do 27th question? Start. Type in your answers. 27th.
Okay. We have B, we have C. Okay.
27th. Okay. The answer to this question is, the correct answer is force of attraction is gravity, which is C. C is the correct answer. So for any objects in this world, any object that you know, attract another object with an equal for with any other object. So any two objects in this world, they attract. Okay. The force of attraction between any two objects in this world is given by force of gravity, which is force of gravity is G m1 m2 by r square, where G is the gravitational constant. So it's a constant number. It's a very small number. M1 is the mass of the first object, m2 is the mass of the second object, and r is the distance between both the objects. So any object in this world, they attract each other with the force of gravity if they have a mass. So all objects will have a mass. So any object with a mass will attract the other object. Then my question is, then why aren't they coming closer? If there is a force of attraction between these two objects, why aren't they coming close?
Come on, guys, we will have a mark for this. The person who answers first, I will give you 1 point. Come on, answer it.
Tell me.
I'll give you 1 mark. Come on, anyone.
Can you repeat the question?
My question is that what I'm saying is there is force of gravity between any two objects. It is not that force of
I'm not
gravity
understanding.
force of gravity only. So do you know that force of gravity exists between the earth and the moon? There is a force of gravity that exists between us and the earth, between
Yes.
any object on the earth. Yeah, you know?
Yeah.
All right. But now what I'm saying is there is force of gravity between any two objects, irrespective of their size. I mean, so these two pens also have a force of gravity between them. Then my question is, why aren't they attracting?
Because magnet
Because-
only can attract metal things.
Because they don't have a magnetic they're not magnets.
Okay, but
They did not have a magnetic. They did not have the same magnetic pole.
no,
If
I'm
they
not
have the
talking
same
about magnetic forces. I'm not talking about magnetic forces. So Earth does not pull you to the ground because Earth is a magnet. Okay, so Earth is not pulling the person or pulling everything towards itself because it's a magnet. So Earth is pulling things towards itself because of the gravitational force. Now, so, and what I'm saying is gravitational force exists between all objects. It's not that gravitational force only
Because the
exists between the
gravitational
earth
force
and
is
the
small.
mass. So
Because gravity only works downwards.
gravity only works down. What do you mean by downwards? So if the person is in the Arctic Circle, so he would stand like this, right? So what is downwards? What do you mean by downwards? There's not downwards, upwards. So
Towards the center of the earth.
towards the center of the earth. So but I'm not talking about this gravitational pull of the earth. I'm talking about the gravitational pull of these two pens. Why aren't they?
Because
So these
their
two pens should
gravity
attract.
it's too small and
Exactly. So the
Okay, who
force
was
of
this? Who was this? What's your name?
me, Heyman.
Haven. Okay,
Amen.
okay. Yeah.
Wonderful. So the correct answer is that the force of a force of gravity exists between any two objects. Any two objects. So even these two pens have a force of gravity, right? But they don't attract each other because the force of gravity is very extremely small. So this gravitational constant that you see, this G, is an extremely small number. So if the masses are not huge, if the masses, at least one of the masses is not significant, it's not huge, there the force of attraction is very less. So in the case of Earth, the Earth is huge. The mass of Earth is huge. Therefore, the Earth is able to attract you. It is able to attract everything else. It is even able to attract the moon and keep the moon rotating in the orbit, right? So it's all because of the gravitational pull of the Earth. And there is gravitational pull of the sun towards the earth, which because of which the earth revolves around around an orbit. Otherwise, if there is no pull from the sun, gravitational pull from the sun, then the earth would, I mean, it cannot revolve in an orbit. So the gravitational pull exists between any two objects, but it is significant only when at least one of the masses is significant. It's huge. At least one of the masses should be huge. So like the sun, like the earth, like the moon, it's that huge. Okay. Do you get it?
Yes.
Yeah. So now the next question. 28th.
So
Start.
Brooke was the winner for the next this one.
28th.
Can't see the choice.
Can we just move up? Anish teacher, just move up.
Can you see 28th question?
Yeah.
No, I can't see it.
Yeah, we can.
Okay, 28th question. We are getting a lot of D's.
Yeah. A D A
Ola
D
is
A
saying
D.
D. Dio
Tarun
is
was
saying
saying D.
D. Iman is saying T. Samuel is saying T. Tobra is saying A. Okay. iPhone. Get sign in with your name. Okay, so we are doing the 28th question. So which of the following statements is correct about a freely falling object? It is an accelerated motion. Is it an accelerated motion? We're doing the 28th question. This is physics. Hey, Lil, focus on solving the problem, no? Biruk, that logic is incorrect.
Yes, Caleb. What do you want to ask? Caleb, you can turn on your mic and ask.
I wondered what the answer for question 27 was.
C, gravity.
Okay, thanks.
Gravity is the right answer. Okay, 28th question. So there is a, so for a freely falling object, so is it an accelerated motion? Do you think a freely falling object is accelerated? So do you, so, so first tell me
It is
if,
a, it
sorry,
is a uniformly accelerated motion.
I think it's uniform. So see, it's a uniformly accelerated motion. That's a
uniform.
perfect way to put it. So any object
How
that is
could it be
falling,
uniform?
it is not uniform. It is uniformly accelerated, which means the acceleration is uniform. The speed is not uniform. The velocity is not uniform. Okay, it is not, velocity is not uniform. The acceleration is uniform. By that I mean that acceleration is a constant. Acceleration does not change. So it is an accelerated motion. So at every instance, this anything that's falling under the force of gravity is being pulled by the earth. And so have you not heard that g equals to 10 meter per second square? So what is this? This is the acceleration due to gravity. So any object in this world will fall with the acceleration of 10 meter per second square. any object. Okay, so so it is an accelerated motion, yes. So A is the right answer. It is a uniform motion, B. B is not the right answer, because if it is a uniform motion, then it has to come down with the same speed. But have you seen that if you drop a ball from a greater height, it falls with a greater speed, right? So how do you know that it falls with a greater speed? So throw a ball, and if you throw it from a greater height, so the bounce, look at the bounce. So bounce will be higher. If the bounce is higher, so that, then you can definitely say that the ball must have hit the ground with a more velocity. So if the ball is falling from a greater height, it comes down with higher velocity, which means that the velocity is changing. The velocity is increasing, right? So uniform motion is not the right answer. Deaccelerated motion. So when will you call a motion deaccelerated? When it's actually slowing down. So when a ball falls, does it slow down, or does it becomes even faster and faster? So it
It
becomes even
becomes
faster.
faster.
So it is accelerated, not deaccelerated. The acceleration of a freely falling object depends on its mass. Do you know this? I mean, if I throw a pen, which is, let's say, 10 grams, and I throw this phone, I don't want to throw this phone, but let's say if I throw this phone, uh, and this is heavier, so which one will fall before? Can you tell me? Which one will hit the ground faster?
The one
The
who
pencil.
Sorry?
The pencil.
The pencil will hit the ground faster than the phone?
Yes.
Why?
No,
Because
the
it's
phone.
lighter than the phone.
It is what? Sorry? The pen is?
The phone will be
It's
fall down
lighter.
before the pencil.
It's lighter. So lighter thing will fall faster?
No, it will be the
No,
phone.
the phone with the phone.
The phone. Okay. But okay. So let me show you one experiment, and then let me show you one experiment, guys. So you will enjoy this. Yeah, go on. Let me show you an experiment, a very beautiful
मनीष
experiment.
वैक्यूम बोलना जरूरी था क्या? It's okay.
नहीं जरूरी नहीं है.
ठीक, okay.
Whether
No problem. Guys, can you please mute yourself?
okay, I'm sharing my screen and you will see. Okay, just hold on. Can you mute everyone?
हाँ मैं वही कर रहा हूँ. Actually मैं करूँगा mute और करूँगा तो
Mute
तुम
all
भी हो
कर दो
जाओ.
ना.
अरे तो तुम भी हो
अच्छा
जाओ.
मैं भी हो जाऊंगा. अच्छा. Okay, let's see this experiment. Let's see this experiment. A beautiful experiment.
This is NASA's Space Power Facility near Cleveland, Ohio, and it is the world's biggest vacuum chamber. It's used to test spacecraft in the conditions of outer space, and it does that by pumping out the 30 tons of air in this chamber until there are about 2 grams left. And it's kind of got an eccentric construction, which is part of its history. It was built in the 1960s as
The video don't have a quality.
facility to test nuclear propulsion systems.
Sorry?
I cannot have the quality of the video.
Okay, I'll send the video message on your chat, so you can have a look at the video there. I mean, you can look it out on the YouTube. Okay, I'll ping everyone the link of the video. So people who are able to watch, you can watch here.
And that meant that they built it out of aluminium to make the radiation easier to deal with. Aluminium is not the best thing, strongest material to build a vacuum chamber out of. So they built an outer concrete skin, which is part radiation shielding and part an external pressure vessel. So this thing can take the force that's present on the outside when it's pumped out to the conditions of outer space. Galileo's experiment was simple. He took a heavy object and a light one and dropped them at the same time to see which fell fastest. Now, in this case, the feathers fell to the ground at a slower rate than the bowling balls because of end resistance. So, in order to see the true nature of gravity, we have to remove the air.
Fikir, can you mute yourself? Fikir, can you mute yourself?
It takes 3 hours to pump out the 800,000 cubic feet of air from the chamber.
Okay, we dropped 2 millitorr in the last 30 minutes.
But once it's complete, there's a near perfect vacuum inside.
6104 manual, 10% open. Station 1, go for drop. PCB 30-1, pressure set point at 240 psi. We are go for drop.
10, 9, 8, 7, 6, 5, 4. Cameras on. 2, 1. Release.
Look at that.
They came down exactly the same. Wow.
Exactly.
Back on the side.
Exactly the same.
Feathers don't move, nothing.
Look at that. That's just brilliant.
All right. So did you get it? What was happening in the experiment? So what was happening is, sorry, go on. Who would like to summarize?
Can I summarize?
Yeah, go on.
They take the ball in the feather. After that, they do experiment and with and without it. Then they do that
So if you're not speaking, you can mute yourself. If you're not speaking, just mute yourself. Fikir, mute yourself, please. Yeah, go on. Yeah, you were saying something. Abel, I think you were saying something.
Yeah, that's me.
Yeah, go on.
When they do the experiment in the air without air, in the vacuum.
Okay.
The vacuum in they release out all the air and the ball in the feather came out fall together because there is no air. And with the air, they fall down.
Fall together.
No, I mean with the air, the ball fell down first.
Yep. So, so the acceleration due to gravity on any object is the same. So 10 meter per second square is the acceleration due to gravity on any object. So if a lighter object and a heavier object, if both are falling from the height, so both will have the same acceleration due to gravity. They will accelerate at the same rate, and therefore their final velocity when the time to hit the ground should be the same. However, when the shape of the body is such that air gets trapped in, then due to air resistance, lighter objects can slow down. Okay, so for example, feathers, for example, parachute. So when a parachute falls, so it traps all the air. So once it traps all the air, So because of the air resistance, the parachute slows down. So because of the same reason, the feathers fall slowly. But if you don't consider the air resistance, even a feather and a heavier object would fall on the same at the same time. And for objects that are, not sick, so this will not so increase the air resistance by a huge amount. So will this will have a negligible air resistance. So if I drop them, they will fall at the same time, although this is like significantly lighter than this object. All right, do you get this?
Yes.
Wonderful, wonderful.
Yeah.
All right, let's proceed. So which statement is correct about the freely falling object? Which statement is correct? 28th question. What is the correct answer now?
A.
It's an accelerated motion, and the acceleration, and D is not correct. The acceleration of a freely falling object depends on the mass is not correct. It does not depend on the mass. For everything, the acceleration due to gravity is 10 meter per second, per 10 meter per second square. Let's do the 29th question. Start.
Mister, we can't see it.
Can't see the choice.
Just move up maybe a little bit. Yeah, fine.
29th question.
Come on, type in your answers, chat in
Can
the
see
chat
it,
box.
Okay, so we're getting the answers. Okay. In this question, so we have got a lot of answers: B, A, B, C. Okay, wonderful, 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 lovely answers. So let's read the question. The velocity time graph of a car traveling along a straight line is shown below. Determine the distance traveled in the first 10 minutes. Okay. Okay, let's look at the graph closely. So there is during the first 1 minute, the velocity is 1 meter per second. Can you see that? For the first minute, the velocity is 1 meter per second. For between 1 minute and 2.5 minutes. So between 1 minute and 2.5 minutes, the velocity is what, 5 meter per second, right? I can read it from the graph. So I can read it here. So when between 1 minute and 3 minutes, 2.5 minutes, sorry, the velocity is 5 meters per second. And between 0 and 1 minute, the velocity is 1 meter per second. And what after that? What is the velocity after 2.5 minutes? What is the velocity after? Because you have to find out the distance, right? For the first 10 minutes. So you should at least know the velocity for the first 10 minutes. So what happens after 2.5 minutes?
4.
What? After 2.5 minutes, what is the velocity?
5.
4
How
meters
do
per second.
How do you get 4 meter per second?
5 minutes.
Why do you say it is 5? So 5, it is only given from 1 to 2.5. Isn't the velocity after? Sashi, can you mute? Okay.
Yeah.
So between 1 and 2.5 minutes, the velocity is 5. But after 2.5, isn't the velocity 0? I would look at it and say that the velocity is 0. I don't see any graph. So which means that the graph is here. The line is here. So the velocity after 2.5 minutes is 0. So if if velocity at 2.5 meter is 0, so will it cover any distance after 2.5 minutes? No. So it has come to rest after 2.5 minutes. So the distance traveled in 10 minutes is just the distance that it traveled in for the first 2.5 minutes, because after first 2.5 minutes, it rather stopped. So I will find out the distance traveled in the first 2.5 minutes. Okay. For the first 1 minute, the velocity was 1 meter per second. So in 1 minute at 1 meter per second, how much will the car run? 1 meter per second for 1 minute, 1 minute. Mental calculations do. 1 meter per second, 1 minute. What do you mean by 1 meter per second? If the velocity is 1 meter per second, it means that every second the car is covering 1 meters. So if the velocity is 1 meter per second, then in 60 seconds or 1 minute, in 60 seconds, how many meters will it cover? No?
Can you tell me the question again?
Okay, the question is that if the velocity is 1 meter per second and the time is 60 seconds, then what is the distance it travels? If a car is running at 1 meter per second for 60 seconds, how much distance will it cover?
X over 60 is equals to 1. So 60.
60 meters, right? So you can directly even say like this, think like this, that velocity of 1 meter per second means that every second, every second, you are covering 1 meters. So I have 60 seconds. So in 60 seconds, how many meters will I cover? 60 meters. Okay. All right. Or you can use the formula distance. So speed equals to distance by time. So distance equals to speed into time. Okay. Distance equals to speed into time. Distance equals to speed into time. Or I can put velocity V, I can put, okay. V equals to d by t. Velocity equals to displacement by time. Okay. So distance equal to velocity into time. So for the first 1 second, 1 minute, the car covers 60 meters. Okay, what about the next 1.5 minutes? Okay, next 1.5 minute is how many seconds? First, we have to calculate all the time in seconds. So 1.5 minutes is 90 seconds, right? For the next 90 seconds, what is the velocity? What is the velocity between 1 minute and 2.5 minutes? 5 meter per second. Do you see that from the graph? The velocity between 1 minute and 2.5 minutes is 5 meter per second. So if the velocity is 5 meter per second I can see it from the graph. So the distance traveled in 90 seconds would be 90 into 5, which is 4, 5, 4,500, 450 meters, right? This is, and so the total distance that will be covered is 60 plus 450, which is 510, which is not there. Okay. Yeah. Wonderful, wonderful. Right. So this option is not there. Just understand the question. So the first, First, first 1 minute, the velocity is 1 meter per second. For 1 minute to 2.5 minutes, the velocity is 5 meters per second. So five for 5 meter at 5 meter per second, it travels at 90 seconds. For 90 seconds, at 1 meter per second, it travels for 60 seconds. So therefore, I can calculate the distance it travels when it's traveling at 1, the distance it travels when it's traveling at 5. And then I will add these two distances to get the total distance it traveled in 2.5 minutes. And after 2.5 minutes, the car stops. Okay, the car stops. So it's not moving. So the answer should be 510. Other way to find the answer is that whenever you're drawing a velocity time graph, you can find out the distance covered by finding out the area under the graph. I don't know if you know this logic, that if there is a velocity, only for velocity time graph, for not other types of graph. If you have velocity time graph, you can calculate the distance traveled as area under the graph. So how do you find out this area? So this is 1, this is 5, and this point is 2.5, which is, so this till here it's 60 seconds. And then you have 60 second plus 90 seconds is 150 seconds. This is basically 90 seconds. So how do I find out the area? So I have two rectangles. For the bigger rectangle, the area is 5 times length 90 seconds, length into breadth into height. So 5, so or 5 into 90. The distance traveled here would be 60 times 1. So the distance traveled here is 60 meters. The distance traveled here is 450 meters. So total distance is the total area, that is 450 plus 60. Is this clear?
Yes.
Wonderful. Let's look at question number 30. 30, start. Start the 30th question.
A.
A.
A,
Okay.
yeah.
Some people are saying A. Okay, wonderful, wonderful. I'm getting A's, B's. Janet is saying B. Fikir, A.
Yes, it's A.
Okay, okay. Okay, so liquids are drawn into a syringe tube when a plunger is pulled out because option A, atmospheric pressure is increased on the sucked liquid. Atmospheric, atmospheric pressure is lowered in the syringe tube. Liquid density is different in and outside the tube. Liquid readily flow from outside to inside the syringe. So see, the liquid C is wrong, definitely wrong, because the liquid density is the same in the syringe and outside of the syringe. The liquid readily flows from outside to inside the syringe. No, this is also wrong, because if you have a needle, right, and just poke the needle and you don't pull the syringe, if you don't pull it, so will the liquid be sucked in? No. So this is also definitely, D is also definitely wrong. Okay, when you pull the syringe, I mean you pull the tube of the syringe, then what plunger, then what happens is so the pressure inside. So you look at the plunger. So this is the plunger. So when you lift this up, so when you're lifting this up, there is a vacuum that is getting created over here. And because of this vacuum that is getting created over here, the pressure is lower here. Okay, the pressure is lower here, and there is atmospheric pressure outside. So what happens is, because the pressure is lowered here, so the atmospheric pressure will push the liquid from the container into the syringe. Okay. So why? So the correct. So because you are pulling the plunger, the pressure here decreases because the vacuum is getting created. Because when the pressure is getting decreased, so the outside pressure will push the liquid inside the syringe. So the answer is atmospheric pressure is lowered inside the syringe tube. Okay, atmospheric pressure is lowered inside the syringe tube. The first A answer is wrong because the A answer says that atmospheric pressure is increased on the sucked liquid. So it's not that this pressure was not there before or that the pressure has increased now. No, no. So this pressure was always there and this pressure has remained the same. What is the difference is the pressure inside the tube has reduced. So which is why relatively this pressure is more relatively. It's on absolute terms, this pressure is the same as before. Okay, so that pressure pushes the liquid in the syringe. Do you get this?
Great, great, great. So
Okay.
I think Abel answered the first question. So what I would just like to ask the students is, do you want us to continue, because tomorrow again is physics. So if you're fine, we can continue for next two questions. Is it okay with everyone? Or do you want
Yes.
to? Okay, nice. So we will do 31 and 32 today, and then we will continue tomorrow. Okay, thank you.
Okay,
Yes, please
let's
continue.
31. Let's do that. Start.
Start, come on.
B.
Type it, type it, type it.
Okay, so B is the correct answer for 31 first question. B is the right answer, the Pascal principle. So hydraulic press is based on that logic, that principle. Okay, I'm not going into the details of the principle, but it's based on that principle. All right. Yep. Let's do the 32nd question. 32nd. Start 32nd. Question number 32. Okay. This is a very simple question. The correct answer is D, kilopascals, because grams is used to measure mass, Newton is used to measure force, kilograms, mass. So Pascal is pressure. So kilopascal is also pressure, right? All right. So that's the end of the 32nd question. A lot of answers were D, and D is the correct answer. So who answered first? You can check. I think.
Yeah, so Delina answered first.
Wonderful,
So
Delina.
great. So can we do one last question, since the two questions were easy? We'll do 33 and we'll end the session. Just one more
Okay.
question.
Yeah, let's start 33. Start.
Yemet says C, Lil says C, Arsana says C. Okay, nice. I see a lot of C and D combined together.
Why do you always jump my name?
What's your name? Sorry. No, I'm not jumping anyone's name.
It was Mitania. Was it you?
It was me,
What's your
Me.
name?
Ebenezer.
Ebenezer. Okay.
Mr.
Yeah.
I'm Mr. Sash.
Yes,
Okay.
tell me.
The 32 answer, who answered it first?
Delina.
Okay, but why I'm saying mine first?
No, I saw Delina's answers first. Maybe you didn't type, you said the answer first. No problem. You can answer the next one. Okay.
All right. So we are doing the
Yannick,
32nd. Sorry, go
Yannick
ahead.
is first to answer.
Okay. 33rd question, the answer is, the correct answer is C, kinetic energy. Uh, so when atoms get hotter, so it gains more kinetic energy. So I'll give you an example. So let's say if you are making some tea or coffee in your kitchen, and when you are pouring that tea or coffee in a cup, so when you're making that tea, so the water gets hot. So when the water gets hot, so you already know that all the water molecules are not stationary. It's not that it's staying at one place. So the water molecules, they vibrate. Okay, they are vibrating, they move here and there. I mean, inside the liquid, they'll not fly outside of the liquid. So inside the liquid, they will be constantly moving. So everything that is in motion will have a kinetic energy. Now what happens is, when you start heating up the water, the molecules start gaining more and more kinetic energy. Okay, so it starts moving very fast, very vigorously. So you might have also seen, when you boil the water starts, actually you can see how the water moves, and it boils. So it gets so much of energy that you can actually visually see that water starts jumping, all the molecules start jumping. Why? Because they have gained so much of kinetic energy. So whenever water gets, or anything gets hotter, so it gains kinetic energy. When you pour that hot water in a cup, then the molecules of the water, because it has so much of energy, it start hitting the wall of the cup. And the wall of the cup, the material that is made up of the cup material, so that also starts to gain energy. So let's say if I am pushing you, right? If I am pushing you with some energy, you will also gain some energy. You will push someone else with some energy. So similarly, when the molecules hit the cup, the material of the cup, they also start to gain kinetic energy. And when they start to get kinetic energy, the cup becomes hot. When you pour a hot water
Mister,
into a cup,
Mister,
the cup also becomes hot.
Mister,
Yeah.
can you ask you a question? Can you
Yeah,
ask
go
a
on.
question?
Yes, yes.
What's the difference between boiling and evaporating?
Sorry, I didn't get the question.
What is the difference between boiling and evaporation? He's asking.
Boiling and evaporation. Okay. So see, evaporation is a, okay, let me explain you. So evaporation is a process that happens continuously. Okay, and it doesn't need to happen at a boiling temperature. Like, I will give you an example. So let's say a bowl of water is lying on a table. Okay, so bowl of water is lying on the table. So all the molecules of water, they have kinetic energy. All the molecules of the water have kinetic energy, and they are constantly moving. They are not staying at the same place. And when they are constantly moving, they pound on each other, so they push each other. So one molecule pushing the other molecule pushing the other molecules, and so on. So although the average kinetic energy of all these, because there are billions of molecules, so through the billions of molecules, not all the molecules will have the same kinetic energy, right? So some molecules may be moving faster, molecules may be moving slower. A faster molecules gets another molecule. That molecule becomes faster. The first molecules may become slower, right? So the molecules, although the average kinetic energy of all the molecules remains the same, molecules might have a different kinetic energy, right? Some molecules may have a higher kinetic energy, some molecules may have a lower kinetic energy. Now, the molecules that are near the surface, okay, the molecules that are near the surface, when they get bombarded, when any high kinetic energy molecule, they hit the molecule near the surface, the molecules near the surface, they gain kinetic energy. And when they gain kinetic energy, they gain the kinetic energy, and so it tries to leave. I mean, it tries to leave the surface. But do you know why is water molecule not able to leave the surface? Because of the force of cohesion, right? Cohesion, you must have heard. So like particles, so when you put water in a glass, right, why does it take the shape of the glass? Why is not one molecule here and one molecule there and one molecule somewhere else? So why does it go below? I mean, why do they stick together? They stick together because they have a force of cohesion. So all the molecules, they attract each other, and all molecules are constantly moving, right? So in this scenario, if you look at the molecules on the top, so they are getting attracted downwards by the molecule that are downwards, right? And at the same time, they are also getting bombarded with the molecules. So it might happen that one of the molecules, some of the molecules near the surface, they gain sufficient kinetic energy. They gain so much of kinetic energy that they overcome the force of cohesion. So the force that is trying to keep them together, the force of the family, the force of the society. So they are trying to put them together, but the molecule gives so much of kinetic energy, and it's near the surface so that it can leave. So even without, no, this is not specific to boiling. So I'm not saying that this is boiling. This is at normal room temperature at every time. So if you leave a cup of water here today at room temperature, if it doesn't boil, will it not evaporate? Yes, it will evaporate. Tomorrow the water volume will be less. Day after tomorrow it will be even less. So all the water near the surface, it evaporates. So it leaves the surface. And think logically. So when the ball, not the ball, the molecules that leave the surface have higher kinetic energy than, comparatively, like its kinetic energy must be higher than the average. That you agree? Because only molecules that have higher energy can leave the surface. So it is leaving the surface. If a molecule is leaving the surface, it means that it has higher kinetic energy than the average molecule. So once it leaves so all the higher kinetic energy molecules leave. And when the higher kinetic energy molecules leave, and kinetic energy is what? The average kinetic energy is directly related to the temperature. So if the kinetic energy reduces, the temperature will reduce. So when the higher kinetic energy molecules leave, the rest of the water has lower kinetic energy. Average kinetic energy keeps dropping. So once the average kinetic energy of the water drops, the water becomes cooler. So evaporation causes cooling. You must have heard that.
Okay.
So it happens because the molecules that are leaving are the molecules that have higher kinetic energy. Okay. So this is on the evaporation. Now boiling. Boiling happens at 100 degrees C. Okay. At the boiling temperature, what happens is all the molecules have a lot of kinetic energy, and at this time as well, the rate of evaporation becomes very high. You see, because all the molecules have very high kinetic energy. So the rate of evaporation, the rate of which, water molecules can actually leave the surface, it increases.
Yeah.
Okay, so this is boiling.